Now that we have our super cool water, let's see it instantly turn into ice. Wow, look at that ice buildup on top of the ice cubes. Hi everybody, thank you for joining me today. I'm Matthew Potter, your community weatherman. So can water really exist below 32 degrees? In today's video, I'll demonstrate this and also show you some really cool experiments you can do at home to create instant ice. In the beginning of the video, you may have heard the term supercooled water. In simple terms, it is water that exists below 32 degrees without turning into ice. How is this possible though? In most cases, the water we see turning into ice contains impurities, like dirt. However, if these are absent in the water is considered pure and does not necessarily freeze once it gets below 32 degrees. Eventually, if it gets cold enough, typically around negative 40 degrees Fahrenheit, supercooled water droplets spontaneously freeze into ice without the assistance of impurities. This process is called homogeneous nucleation. So for this experiment, all we need is a bottle of purified water that's undergone the process of reverse osmosis. In short, reverse osmosis is the process of removing the large majority of contaminants from water by using pressure to force water through a semi-permeable membrane like synthetic lining. Through this process, any impurities that would allow for ice formation are removed. Now we're going to put our water in the freezer for about 2 hours. And by doing this, we're going to allow the temperature of the water inside the bottle to cool down below 32 degrees. Now here comes the hard part. Now we got to wait. Okay, so now our 2 hours are up and we're ready to head into that freezer and get our water bottle. Now when you do this, you're going to want to be very delicate with the water, because if you set it off, you could create the ice right away. But we want to see this out here. And look at that. You can actually see that we still have our water encased in our water bottle. Now let's head over here and we'll make some ice. Now before going full steam, you will need to prepare a frozen plate of water and then put a couple of ice cubes on top for good measure. Now that we have our super cool water, let's see it instantly turn into ice. Wow, look at that ice buildup on top of the ice cubes. And this is only possible because of the water being in a supercooled state. By introducing the ice cube to our supercooled water, the ice is acting like an impurity and causing the supercooled water to change its internal structure and change into ice. You can make some pretty cool structures with the ice, or you can try to build it as high as you can before the ice tower falls over. For the second experiment, we're going to be putting the ice into the water bottle. Carefully unscrew the cap, and then because of the condensation that develops on it after you take it out of the freezer, you're going to want to wipe it down so you can see it a little more clearly. Then we're going to put our ice into the supercooled water. And wow, look at that. You can see the ice instantly form at the top where the ice comes in contact with the water. And then eventually you can see that the ice develops down toward the bottom of the water bottle. To visually see what's going on in both experiments, let's take a look at the molecular level. Inside the bottle of supercooled water, we have tons and tons of water molecules that are packed together and are randomly moving around. But once we introduce an impurity, which was the ice cube in our experiment, it gives the molecules a place to form into ice. The fancier term for this process is heterogeneous nucleation. The water molecules slow down and space out into a hexagonal lattice pattern, resulting in ice. This starts a domino effect that runs through the rest of the bottle. Now there are some caveats with this experiment. For instance, we use 2 hours to freeze our water. However, it could be more or less depending on the temperature of your freezer. And another thing to consider is the type of water bottle you're using. Some brands are better than others. I would actually recommend Fiji water bottles. They seem to be the best. A cool, real-life example of water quickly turning into ice occurs in the development of a unique-looking formation in the clouds called a fallstreak or a hole punch cloud. These are a large circular or elliptical gap in a cirrocumulus or altocumulus cloud field. The clouds are typically comprised of supercooled water droplets, and when airplanes travel through the cloud layer, This creates enough of a jolt to cause the droplets to freeze into ice crystals. These ice crystals then attract more neighboring supercooled water droplets because the saturation vapor pressure with respect to the ice crystals is lower than the saturation vapor pressure with respect to the supercooled water droplets. As a result, the crystals grow, eliminating the water droplets, and the crystals become large enough to fall out of the cloud field, leaving behind the hole. The process of the ice crystals growing at the expense of the water droplets is called the Bergeron process. If you liked today's video, please hit that like button and leave a comment down below, and also subscribe to my channel to see more weather-related content in the future. Thanks once again for joining me, and I'll be sure to see you soon.